the schedule a little bit. So, welcome. My name is Ingeborg. I have the pleasure of moderating this conversation about the topic built with blue biomass on behalf of the Royal Danish Academy, Institute of Architecture and Technology. Now, before I introduce the panel of today, I wanted to briefly introduce you to the field of blue biomass and our reasons for putting just this topic forward in this conversation today. We all, or it might seem like we all at a conference like this today, are becoming aware that the building industry accounts for nearly 40% of the global greenhouse emissions. It is a massive consumer of resources and a giant producer of waste. If we are to successfully flip the industry from one that in reality prohibits sustainable development to one that actually contributes to sustainable development, we have to think creatively and holistically when we do things differently. We have to find and look for and search for new collaborators, new professions that we can work with, and new resources. One of the keys to this transition could be biogenic materials and the resources in the blue biomass. And that is the topic of today. What if we looked beyond our existing and normal material palette and looked below the surfaces of our water bodies and considered if some of these strong, fast-growing, locally abundant biogenic resources could play a part in this transition? Could algae, seaweed, shellfish, seashells, and so forth be actual alternatives to carbon-heavy materials? Could a focus on the resources in the blue biomass help us cater to the needs of the building industry without compromising the blue biodiversity? Maybe even strengthen the ecosystems and life below water? These are some of the questions that I hope we'll learn more about today. The occasion for this session today is the recent launch of a new international building with blue biomass network, which we'll hear more about in a little while from my colleague Paul. First, an introduction to the panel. Next to me, we have Paul Nicholas. Paul is an associate professor, my colleague at the Royal Danish Academy. He is head of the building with blue biomass network, and Paul will introduce the network and the scope of the network in a few minutes. Next to Paul, we have Catherine Larsen. Catherine is an architect, and she is the owner of Catherine Larsen Studio and the founder of Reef Circular. We have a prototype with us also, a startup that uses shell waste to create 3D printed reefs and thereby regenerate the life below water. I think Catherine has also done a lot of research and artistic experiments using other types of blue biomass, and maybe we'll get to hear about that later as well. Next to Catherine, we have Peter Vangsbo. Peter is an Associate Director for Climate and Sustainability Services at ARBUC, which is also a founding partner of the Building with Blue Biomass Network. I have to get used to say that. And Peter has extensive experience in the larger scales of sustainable innovation and can help us find out about the potentials of this topic.
Sorry, it was me who gave that crazy name. Next time I'm naming a network, I'll do it better.
It's good to know. You should have told me in advance, Peter, but I'll try not to hold it against you as we proceed. And then finally we have Tobias Ørstam. Tobias is also an architect, and he is the founder of seaweed, which you can go and visit at the conference and see his products. seaweed is a company that designs, produces and sells acoustic mats made from eelgrass and has been doing so successfully for about 10 years. So welcome all of you. I'm really looking forward to this conversation with you today. And now I'll pass the word to Paul first to introduce the network. Please, Paul.
Great. Thank you, Ingeborg. So I think uniquely on the panel I have the opportunity to show some slides to help with this introduction, but it's really fantastic to be able to share our network with you. The Building with Blue Biomass Network is a... Can you hear me, actually, first of all? Yes, okay, great. It is a difficult name. The Building with Blue Biomass Network is a global innovation network. It is funded by the Danish Ministry for Education and Research. And we have the aim of sharing knowledge and identifying research that can accelerate our ability to make and also to use building components that are made from blue biomass. And that means materials that come from aquatic biomass, which includes micro and macro algae, seagrass, mollusks and seashells, which we think can play a key role in a shift to a bio-based architecture. The network creates a community, and that community brings together research, industry, and policy. It's been initiated in 3 countries that have quite significant marine ecosystems, cultures, and economies. That's Denmark, Australia, and the UK. And it brings together a set of anchoring or founding partners, which are the Royal Danish Academy, DTU in Denmark, UCL in the UK, Queensland University, QUT in Australia, and our industry partners, Arup and 3XN and GXN, who operate across all those geographies. I think the great thing about this partnership is that it actually allows us to assemble expertise across the entire value chain. So to put together the people who are growing and cultivating materials, the raw materials, with the synthesis of those into architectural materials, understanding of the fabrication processes, the design contexts, but also the larger scale regulatory and policy frameworks that we can fit into. So I suppose one question is, when we talk about blue biomass and these kinds of materials, it's much more commonly in the context of food or pharmaceuticals or fuels. And so one question is, why is it important that we engage with this context and these materials from an architectural perspective? I think, if we want to decarbonize the construction industry, we can't do that using the conventional materials of today. To get to 7.5 kilos of carbon per square meter per year, we need to start to replace the more carbon-intensive materials with something else. And I think, the shift to bio-based architecture, bio-based materials recognizes that we already actually have a really great way of creating those raw materials, and that is photosynthesis. But for some reason, this discussion has been very blinkered. The focus is really based entirely on our conversation is based on our land-based materials, when in fact 80% of photosynthesis happens in the water. And here we have fast-growing biomass, which includes materials like kelp, which can grow at 30 times the rate of trees without any need for fresh water, nutrients, fertilizers, or pesticides. So if we were to cultivate those materials at larger scale, we'd be cultivating them in the water and off land, and there's 2 benefits to that. One is that it doesn't add increased pressure and impact onto our land resources, which are already under a great amount of pressure. And secondly, that regenerative farming and cultivation can actually play a key role in increasing biodiversity and cleaning and removing nutrient overloads from Denmark's coastal resources. We promised the EU that by 2027 we will bring all of our coastal marine environments or ecosystems up to a good level. I think currently it sits at something like 5% that reaches that level now. So there's a real positive role that these materials could play even before they become building materials. Another aspect of these materials is that they can be locally sourced and cultivated regionally in Denmark, either from marine environments or also as cascades from other industries, which could be the food industry, could be the pharmaceuticals industry. And that can support regional economies through Denmark, Scandinavia, and also, I think, could support a new market for those producers. So the idea of a construction market for aquatic biomaterials would be a lower level of entry, lower costs, and with less regulation than the food and pharmaceutical materials that those producers are currently using. So where do we stand today in terms of development and research? I think that there is a very large amount of interest, and particularly research, in pilot products, but there is very few products that have made it to almost to market or through to market. And I think there's two examples of this that we have here today, and we'll hear from in a moment. But in terms of moving through the regulatory environment, we are perhaps not quite there yet, and this is very much what our network wants to support. I think a number of challenges that we have we do not yet have the very large-scale aquaculture industries in Europe, which already exist in other parts of the world. The materials themselves have an inherent natural variability. This is something that means that if we were to grow the same material, use them in products in one part of Denmark, they would have different expression, different material properties than the same materials grown in other parts of Denmark. And this poses a challenge to moving and standardizing these materials. Another challenge is that they are perhaps not as easy to fabricate and to work with as some of our other bio-based materials. So here we really need to be working interdisciplinary with material science, also with more advanced modes of manufacture, and to bring these together to start to create products from these materials. Here we see some of the products that we are actually creating in our research centre, But I think maybe the largest challenge that we have is that it is one of imagination and creating the future. While there are definitely really good examples of the tradition of using these materials in architecture, it's not a rich tradition. And I think this places a big emphasis on needing to invent and create the building systems of the future that would use these materials within them. I think this will be my last slide. A really key part of doing this has been done with our master's students over the last month or so at Computation in Architecture, where we have been working to think through and to prototype some of these building systems, with the idea of trying to speculate about 100% blue biomass building facade. And we have some of the results of that work exhibited downstairs. So I'd invite you all down later to continue the conversation and have a look at some of those steps towards a building with blue biomass. And I think that's my last slide.
Thanks, Paul. Maybe if we can just switch to the start screen again. Thank you, Paul, for sharing some of the scope of the network. Now let's move to the panel. So Peter, you're also a part of the founding group of this network. Could you say why ALP has chosen to focus on this area and what you see are the potentials on the large scale?
Yeah, ALP is a global engineering architect company, and we're really trying to set the boundary. Our vision is to create a better world with a lot of innovation and a lot of knowledge. We work a lot in partnerships, and the many clients that we are working with, metro company, the energy utility companies, Ørsted, and others, they have the same vision as we do, trying to be explorative on how we can use these large-scale infrastructure projects as a test ground for investigating new materials like the one you see here in front of me, or the one that Tobias is presenting with soon. So I'm a kind of a mediator in this, trying to bring some of these very unique products in place, but also having the view from the EU policy side. What is going to be the future bottlenecks or opportunities? So I'm trying to look at the barriers in the market, and I'm trying to connect the entire ecosystem with asset managers and investors to really get some more speed in this blue biomass transition.
Thank you, Peter. And just to hold you to your point about trying to push the boundaries and set new standards. So in your vision, let's say 10 years from now, where would we find new biogenic materials in construction?
Let's just talk about next year.
Yeah.
Today we are here to celebrate reduction roadmap and what is beyond reduction roadmap. The Danish push on setting very ambitious limit value on our build industry is really pushing not just the sector as such, but the entire supply chain. And I hope that many of you here in the audience are a part of that supply chain. This is a really joint push we need to do. And from my perspective, I see that we have the attention of the world. A lot of international delegations, a lot of companies are looking to Denmark to explore the reduction roadmap targets and how we work with these type of building materials. So with next year's even further strengthening of the reduction roadmap or the limit targets, we see a new trend in the LCA that nature and biodiversity are going to be a reporting requirement for all larger scale companies. Nature and biodiversity is our business model opening for accelerating testing of these new products. When companies like the Metro Company and Castle need to report on their performance, they need to investigate throughout their supply chain how they source this type of material and how it actually benefits not only the environment but also society, startups, and social value as a whole. So we're not talking about a 10-year horizon, we're talking about 6 months horizon.
I'm sure that's good news for you, Catherine.
That's excellent news. Yes, please say more of this to the people who don't believe there's a market for this. There's actually a $1.3 billion artificial reef global market, and this is something I keep having to explain to business people, that just because it's good for the environment doesn't mean it's also not good for business. So yeah, I see a big potential in that also as well. That's one of the reasons why we started Recircular. When we started, actually, nobody believed in the concept. We started developing the shell bioconcrete actually in the floor of a kitchenette. That was a clothing boutique in Copenhagen. Our biggest barrier actually to beginning to scale and get the lab work for patenting was access to a lab, because in Denmark there's no material science laboratories for startups that also combine with fabrication spaces, unlike in Holland, where there's something called Blue City, where scientists and designers work together. We had to convince the people at Symbion, where a lot of the pharmaceutical startups are there, why we should get access into their laboratory to develop a new material for biodiversity versus something to do with pharma. So we had to be one of the front runners in that and convince people that, you know, this is the future here 2 years ago, 2.5 years ago. And already we can see that we were right on the pulse, because I told my co-founder Shannon when we started, I said, by the time we've developed this and patented it, the market will be ready for us. And so we can feel, we're about 4 weeks away from being patent pending, we can feel the market is very ready for us. We're very excited about that.
That sounds really interesting. And sometimes when we talk about materials like this, it seems so innovative in like, as you explain it, like it's a totally different way of thinking about architecture. But actually, in the history of architecture, we've also looked at these materials before, and I know, Tobias, that that's one of the reasons you focused on eelgrass and seaweed and looked to these types of materials when you started working after graduation. So could you tell us a little bit about your entry into this field and experience of that?
Yeah, so basically everything started when I was an architect and was so confused about the material that you can use in the construction industry, because when you want to do something sustainable, you are somehow trapped in between regulation and sustainability. There was no joint together, so in the beginning of the zoo, we were looking back into the history of the old use of leather, which really was this kind of, let's say, proof of our concept of zoo, that this is really a long-lasting material, it really performs well. So, and then we just have to convert this, let's say, tradition-based material into a more contemporary material, and that took some time. It also took some time to convince people that a ground ceiling is amazing, and if you have something natural, it's also something that is high value, because most of our products on the market are so processed, so you have no idea where it's coming from. So this is also another way of, let's say, putting some kind of poetry or something that's tactile into the building construction industry, because we are used to have products where you have no idea where it's coming from. So building on that, and of course sustainability, and then creating a product that is in the same level as mineral, as other types of materials. Just be launching the highest fiber in Denmark, so you can be in all ceilings. So now we have to say, let's say limits on the scale. So it has been a long journey of, let's say, growing the awareness of natural materials, of course, by developing meanwhile.
And can you sense the same shift in the market and in the conversation as both Peter and Catherine are describing?
Yeah, for sure. I mean, just here building green. I mean, some years ago it was like few, let's say, sites where you can find something that was actually natural. So now it has been changed quite a lot, as you can see. And so for sure everything has changed. And now, I mean, you can also see on our projects, it's just getting bigger. And last year we just made a IKEA with a full ceiling and IKEA. I mean, in the beginning it was more this kind of first movers, high-end customers who want to go fast and also was intrigued by this natural material. But now we can see it's getting a bigger audience, and that's our goal, because the more eelgrass we can get out on the market, the more CO2 we can, let's say, put in a CO2 bank in the building. So that's the whole purpose of seaweed.
Even public clients are also starting to look into this and really trying to test the options out.
Sounds good. And Paul, I wanted to shift back to you, because the new network work is international. So some of the materials we're talking about here are local Danish, naturally grown materials. So can you tell us a little bit about the values of working with someone across the globe on this? Because there must also be some differences in the approach. Or so can you share a little bit more about the collaboration internationally?
Yeah. So it's interesting. I mean, one of the problems actually with beginning the project was trying to find the funding bodies that would support such international collaboration. There's a lot, I mean, obviously, of possibilities within the EU, but if you want to go outside, it's more limited. And that's something that we thought was very important, precisely because of this difference. Even though you have kelp or mussels or seagrass in all of these locations, you also have histories of production and cultivation. They're quite different, and they fit into different cultures. One example of that is some of our collaborators in Queensland are doing a lot of work with growing very, very large quantities of microalgae. And they're very interested in this because within a few days, this microalgae can suck a lot of carbon out of the atmosphere. And they can do that in Australia in very large open air, basically farms. That's something that is impossible to do here in Denmark, where we need to put things into pipes and have much more controlled situations. So there are real geographic and climatic factors that impact on how the same materials might be produced or might also be used very differently in these different circumstances. But we're also really aware, and one of the kind of key ideas of the network was that there are lots of insights in these different locations, and what we have not, what we're trying to do here is to put them together and to connect insights into production in Australia with perhaps fabrication, or particularly, as we're describing here, I think really sort of insights into the future of bio-based materials. Our market is quite a bit ahead of other parts of the world, and to be able to make connections there. I think for the research perspective, it's also really interesting, particularly because what we are seeing is, while the materials are different, there is also really a very shared interest in bioeconomy and a shared interest in understanding how cascades and perhaps residuals of these materials can move into building products. So trying to think about getting multiple benefits from the same raw materials. And that this is really an area where there is a lot of shared research happening between Australia, the UK, and Danish.
Interesting, yeah. And Catherine, your work sort of also transgresses the boundaries between a private company doing regular architecture work and doing research or even artistic experimentations. But you're also very internationally connected, and it's also I also have an idea that you work very interdisciplinary.
Yeah.
So could you share a little bit with us about the value that you see in an international initiative like this, and how that might help you go from prototypes to eventually a market?
Yeah, I think one of the big benefits is mapping the bioeconomy potentially. That's something we've had to do on our own through reaching out to different fisheries, reaching out to different ecosystems, and trying to figure out what resource is here in this location. Is there a waste resource? Can we use it? I did a design project in Poland for Academia Design Days where I actually learned that there's entire amounts of Persolaria that were over-harvested and now no longer grow in floating fields and only grow attached to rocks because they were over-harvested for carrageenan production. So I think just because something is a resource in one place as a blue bioeconomy material doesn't necessarily mean that even if the same species is present in the Baltic Sea on the other side of Denmark, it's still a resource that we can use. So I think that for me would be the real potential of that network, is actually the awareness of what can we responsibly use as a biomass in this area, what could we grow, how could we grow it, how could we then use that as a resource.
Interesting. And Tobias, if I could ask you, because you are actually doing this already and you have this production system running, so could you tell us, if we go from the global to a little bit more of a local perspective, also as Catherine points out, the specific materials, could you tell us a little bit about who you work with in your production in order to get that functioning in a way that's both giving you the materials that you need for your production, but also respecting the local natural environment?
Yeah, so basically we have quite a lot of links in the supply chain because we are dealing with a natural fiber that comes coming from the sea and goes to beaches. So we are talking together with municipalities. That's always the first ticket to get some biomass, getting the allowance from them. Talking to Kystdirektoratet to see how is the regulation about handling biomass. So that's also part of it, but also getting new farmers to pick it up on the beach. So has been a big expansion for us to somehow get some local partnerships, but also working at areas where jobs are not maybe not. We are also working, for example, with former mink farmers, because we have all the fields, they have the knowledge about doing something, but the story about mink. So that's amazing also how actually we can start with partnerships quite local, but also actually in a global context, because if we're starting to spread out our activities with eelgrass from a small farmers, but also with social economy. So we're also working in small scale, which for example at Amager, we're using Amager skovhjælper, which are a very small part of the supply chain, but it's crucial for us to have the small and the big one, professional, to get the full chain about biomass. And then of course we're at the same time working with quite, let's say, low technology based farmers. Then we're working with, let's say, high-end, let's say, modern equipment that we're producing. So combining tradition and farming together with, say, the most modern machinery we can get. That's how we have been trying to join, let's say, everything here. And I think from the beginning the mindset of Zoo has been not in Denmark, it has to be more like a global mindset, because we see ourselves more as a segment, because Denmark is a small country. And what we are trying to do is a more global thing, because eelgrass is around the globe. You can basically pick it up more or less in most part of the world. So that's the idea. We shouldn't be a centered organism in Denmark and just spreading out, but we should have local partnerships. So, I mean, yeah.
So that's one way of scaling your business. But could another also be, because I remember you told us that the material board has great acoustic properties, but also insulating. So could you tell us a little bit about the potential in order if you were to replace an established insulation company?
Yes. So that's the amazing thing about eelgrass. It has so many benefits, and it's because it's coming from the sea. So first of all, it doesn't burn, because it has already been impregnated with salt. So we are so many steps in front of most bio-based materials, because it doesn't burn from the beginning. And then it also insulates. So it has the same value as normal mineral wool. But let's say for us in Seoul, the first approach has been to work with the more or less present material, something you can see, because the acoustic properties is the insulation values. We have the highest value according to acoustics. Now we have the highest value in fire rating. And I believe we also have some of the best values according to LCA. If you take the A1 to A3, then so combined, that has been the mission from the beginning, to have somehow sustainability and performance linked together, because that was for me the missing link in the whole business, because the only way we can scale with the bio-based material is performance, because we never get to a carbon sink if we don't have scale. We need to have a huge scale, and we need to not just work in Denmark, we need to think globally to have it spread out.
Peter, if I can catch you. so that sounds really interesting, Tobias, and it's a very inspirational journey you've been on with Sue. But another way of sort of minimizing a building's carbon footprint could also be if one material or one element in a building could have multiple abilities, both acoustics and insulating, so that you could replace an existing material with doors, for instance. But there are also some I imagine structural challenges in this. And Peter, you were very positive at first, saying that the potential is right around the corner, and within 6 months we'll experience a change. But could you try and say a little bit more about how many of our existing building elements that we have to apply to the way we build today could we replace with good biomass materials in, say, the 6 months, a year, 5 years? How much?
Yeah, so right now, Arrow are engaged in designing the new metro line M5 here in Copenhagen. And our client, the metro company, have said we really need to step up and improve our CO2 reduction for M5. Our target is to lower the CO2 footprint compared with M4 with 50%. So we are trying to work around different type of composites, different type of concrete mix, but also the facade component of one of our stations. We want to actually perhaps investigate or push a test of seaweed, both because it has such unique acoustic properties. Now there's not a discussion. There have been a discussion for a long time on the fire performance. The fire certificate have not really met the criteria. Now we have a new situation that we need to explore further. But the benefits that you're talking about was related to the structural part. But I want to mention that the project that we are working on also needs to have from a viewpoint, a very artistic, interesting approach. And I think from a tourism perspective, I think it would be really unique if we, as first in the world, can use blue biomass in the design of our metro station. So I think it have a lot of storage settings. I think it have a lot of different type of benefits. And these benefits are really the game changer when we are speaking with our clients. We need to come up with a much more wide business model presentation. This is not about what it can perform, it's also about the associated benefits, the externalities of these projects, that it can create local jobs, it can improve the oxygen level at the benthic marine ecosystem, it can extract the nutrition in the water as Paul was mentioned. I think this type of very broad business model is the narrative that many of the clients that we are working with require. They would really like to get facts on that for their future EU reporting.
Okay, so Catherine?
Yeah, data is king. Yeah, we found this out very early on with our own testing. People simply did not believe that it could host life until we could prove it. So this summer we installed 24 reefs off the coast of Hundestal. We installed 10 that are installed on a seawall about 1 meter below sea level. We installed another 10 on the seafloor. Sorry, 14 on the seawall, 10 on the seafloor. The one on the seafloor actually inspired by stone reefs, which were originally from the Baltic Sea. And then we set up cameras with continuous monitoring. Now apparently the way that reef projects are usually monitored usually involves a GoPro for 30 minutes once a quarter where you count the amount of fish. With the continuous monitoring, we could see that after 4 months, our test locations compared to control had significant more fish visiting. And in total, we have had over 2.3 million fish visitors at our reefs since July, which is very tremendous for us because we were only expecting to see 1 or 2 fish species, but we've seen a whole bunch. We've even seen seals, and we've even seen cod coming to the area to rest on our stone reefs. So for us, that's really the proof in the pudding, and once we could show the videos from that continuous monitoring, we noticed a huge shift in the way that our company was treated, and also a shift in how our technology was treated.
So pointing to data as the power tool to sort of get these new innovations. I know that's also something regarding your new fire coding of the product, Tobias, that's been key in order to push your product forward. Peter, back to you again. So who can help people like Catherine and Tobias who have the good products, who have the innovation, who have the ideas, to sort of push this data through and help your clients who want these products in their buildings, in their projects? How can we sort of support this facilitation of a change in the regulative system, in the improvement system, so that these new products that are ready, these new materials that we have in abundance can actually be applied?
Yeah. So I guess Catherine and Tobias, we money talks. We will get these products out when there is a regulatory requirements, and we see that more of the multinational or the big international companies, they're setting biodiversity net gain targets. That's an investment initiative from the company to go out and play around with a regenerative approach for the areas that they are working on. So the whole push from Ørsted on offshore wind, these offshore wind installations is an ideal opportunity for us to support Ørsted to meet its target on a net biodiversity or net gain biodiversity pivot.
Interesting. And before we go to questions from the room, I just wanted to hear each of you, just one final time, potentials seen from your own perspective in this field, the blue biomass. Tobias, what do you hope if we meet here next year or in 5 years' time? Where do you see your company and eelgrass in general?
I think my big hope is that we're changing two things. We're pushing for the regulation to have more bio-based materials integrated and favored somehow instead of the normal materials. And then another thing is also to change the tenders. It could be the tenders for building projects like you have to favor, for example, the LCA and the A1 to A3, not the western part, but the initial, because they're the only thing we can compare. So that would be amazing to put a value on that and put actually a price on it, because CO2 is a price. I mean, we have to change our mindset. It's not money is the price, of course, it's a value. The CO2 is going to be a price because we are too late to do something, so we have to value that. So I think that's my hope.
Thank you. Peter?
Yeah, our hope is not a magic group who can change the market. We can change the market in partnership with you guys, with the entire supply chain. And I would really like to see that we go from a niche to a global scale on these opportunities. We can only do that in partnerships. So for me, I would like to see a metro station in Copenhagen where we are using Tobias' eelgrass. I would like to see a new ring road infrastructure in Copenhagen where we are using these type of reef structure to regenerate the marine environment after we have been doing a big infrastructure somewhere.
Interesting. And Catherine? That also intersects with my goals. I was going to be ambitious and say we'd really like to develop a plug-and-play solution for offshore companies and offshore products. That's our one of our big ambitions, is to take this not just as a B2G product, which is where we've started also in the UK, but to actually transition it to private projects, to offshore projects to help improve and restore the ocean's biodiversity. And what we see is the big potential for our product is not in replacing cement or concrete, but actually by acting as the most biologically friendly material to cover that. Has the perfect pH for sea life. We've basically developed it in the lab for biodiversity, and so we really think that our product could come on top and serve as that starting point to help encourage biodiversity to come back to an area.
Yeah, I mean, I think I would like to see or hope for that the research sector and also the algae sector becomes more aware of the potentials and possibilities of the built environment. There are crazy projects at the moment where kelp is being harvested, baled, and then sunk to the bottom of the ocean to store the carbon.
Yeah.
And there's no awareness that we could be using our buildings, we could be using our built environment to be doing the same thing, getting so much more value from that awareness. So I think raising the awareness of the built environment in research sectors and also in the algae sectors is something that I also think is perhaps the other end of this, of raising awareness within our own sector as well.
And how about the students at computation? Do you imagine when they graduate in a very short time?
I already hired one of them.
Yes, we're already on the way, exactly. But I think this is also a very important part of it, is putting our students into future practitioners who are skilled, knowledgeable in the materials, skilled in the technologies, the design approaches, the conceptual frameworks with which to use them. And of course a large part of that is around both the sustainability side, but also the innovation aspects. So this, I think, is already underway. Yeah.
Sounds good. And now I think we have Thomas somewhere ready to share a microphone. If we have any questions or comments from you guys, please feel free. We have one over here, Thomas.
Hello. I was just wondering, how do you deal with the problems with poor water quality, where mainly eelgrass cannot grow and mussels cannot live?
Is it a question for Tobias, maybe?
Actually, for all of you.
Yeah.
I can answer that because we're always asked if we should put our reefs in by the fjord to save by the fjord, and always our answer is if we put reefs down there with one fish coming every 6 hours, it's not really going to do much. We have to actually solve the problem at the source when it gets that polluted. I even know that there was a pilot project involved with mussel farming by the fjord to try and filter the water, and the mussels asphyxiated. So my response is always, if nature's filters can no longer survive in the water because mussels and shellfish filter the water, our reefs aren't going to do much until that's cleaned up. After it's cleaned up and the filters are starting to do their job, we can help with the oyster restoration work, we can help with some of the mussel line work, we can also help